Hello friends, welcome you all IS with Arihant and very good afternoon to everybody. And this is the channel of IAS with Arihant. If you do not subscribe yet, subscribe the channel and share the class with your relatives, with your friends and those aspirants who are preparing for UPSC and state PCS exam. Right? If you going to prepare UPSC and state PCS exam, you must have this book Prelims Possible by IS with Arihant. Right? So IS and state PCS exams, you need to a proper guidance, a proper concept. You need to understand proper concept, basic concept, because in the UPSC prelims and state PCS prelims, they really asked a basic questions from the topic. So this prelims possible book have 3000 solved MCQs, PYQs, and this is the general science book. Also, there are many books for many subjects like history, political science, economics, geography, prelim possible with Arihant. All right. Now, why you purchase this book? You must understand the features given in the book, right? I think the board get hanged. So wait a 1 minute. I'll just start it. So how was your Holi? Tell me. So in the general science, we started subject physics. In physics, we finished first unit, units and measurement. And in the previous class, we started second unit, motion and Newton's law of motions. That means second chapter is mechanics, right? So we are talking about the prelims possible book by Arihant. And what are the features? The features are it is chapter-wise, topic-wise division, topical mind map, 100% error-free explanation, knowledge plus for typical questions, and 3,500 plus PYQs bullets. So if you are get this book or you purchase this book, you getting all these features given in the book, and this is really having such a good and amazing content in this book. So you really purchase this book for your preparation. And if you want to qualify your prelims in one attempt or a first attempt, you must have this book because it guides you very well in your preparation. Now let's start the chapter. We almost finished the first topic, motion. We almost finished the first topic. We understand all the given points here, and now we are going to discuss question and answer. All right. Question third. Question third. A vehicle covers half the distance with uniform speed v1 and the other half with uniform speed v2. The average speed of the vehicle is option number A, v1 plus v2 upon 2, v1 plus v2 upon v1 v2. Option number C, v1 v2 upon v1 plus v2, and option number D, 2v1 v2 upon v1 plus v2. So Now, let's discuss the explanation of the question. A vehicle covers half the distance with uniform speed. Here, make the diagram from A point to point B. D by 2, half the distance, and speed V1 and the other half with uniform speed V2. So, other half is D by 2, this is the distance, and speed V1 and the other half with uniform speed V2, the average speed of the vehicle is. So, time. Here the time is T1 V1 and T2 V2. Alright. Let the average speed of the vehicle is, is your answer. Right. Let the T1 and T2 time taken by the vehicle to T1. Here is the T1 is equal to. Now, what is the formula of speed? Distance upon time. Distance upon time. And if we want to measure the time, the formula is time is equal to distance upon speed. So, T1 is equal to distance upon what we are given in the distance, T by 2 upon T1 V1. This is the, V1 only. We are talking about speed, so this is the V1. And we are talking about T2. Time T2 is T by 2 upon V2. Right? So, what we get, the total time we get D by or D upon 2V2. Right? The total time we get T by 2V2. This is our total time. Clear? Now, we are going to measure the average speed. We are going to measure average speed. What is average speed formula? So, you must say total distance upon total time. Total distance upon total time. Am I audible and visible to everyone? Am I audible and visible to everyone? Okay, everything is clear? Now, equation 1 we put in the formula, that is total distance upon total time. That means what are the distance we get from here? Total distance is D upon D by 2, or we must write here D upon V1, D upon V1 plus D upon V2. This is our total distance upon total time. Alright? V1 to V2. Clear? Now, what we get from here? We get from here total distance. Let's rub this first of all. Let's clear this diagram and use the space. From here, the total distance D upon, now D upon D by 2V1 plus D by 2V2. So, let's check out the common factor is D by 2, right? So, let's check out the common factor D by 2 here, and what we hear, V1 plus V2 and V1 multiply V2. This is the whole equation we get. So, now cancel out D by D, alright? D by D, and then we reciprocate this whole equation. What we get now? We get 2V1 V2 upon V1 plus V2. This is our answer. This is our answer, and the option number D is the right answer. Option number D is the right answer. I hope you understand this numerical portion of question number 3. Now, let's move on to the explanation. Answer D, a vehicle covers half the distance with uniform speed V1 and the other half with uniform speed V2. Then the average speed of the vehicle is 2V1 V2 upon V1 plus V2. Let T1 and T2 be the time taken by the vehicle to cover the first half distance D by 2 and next half distance D by 2. This is the diagram. We made it. Right. T1 is equal to T by 2 upon V1. this the time 1, and T2 is d by 2 upon V2. The total time is d by 2V2. Now let's talk about average speed. We find the average speed according to the question. V is equal to total time upon total distance. This is the formula of average speed. If you find out the average speed, you must put this formula and also put the given values in the question. Total distance is d upon d by 2V1 plus d by 2V2, right? So the explanation is d by 2. They extract the common thing here, and this is the whole equation. We cancel out d by d, and what we get, we reciprocate this. So the denominator value puts upward here, right? 2V1 V2 upon V1 plus V2. This is our final answer. Clear? Now comes to the next question 4. Who is the first person to define a speed? Galileo Galilei, Newton, Kepler, Ptolemy. What is the right answer? Okay. Now, one by one, we discuss all the given options. You know everybody about Newton. We already discussed Newton's law of motions in this given chapter. Newton gives 3 laws of motion. 3 laws of motion, right? Kepler. When we are talking about Kepler gives what? It gives 3 laws of planetary motion, right? It gives 3 laws of planetary motion, right? 3 laws of planetary motion. And when we are talking about Ptolemy, who is Ptolemy? Ptolemy, his complete name or full name is Claudius Ptolemy. He is a very good astronomer, mathematician, and also a geographer, and he is famous for his very controversial theory of geocentric theory of the universe. Geocentric theory of the universe given by Claudius Ptolemy. It's a very, very controversial theory, right? Now, comes to the right answer. The correct answer is option number A, Galileo Galilei. The first person who defined speed is Galileo Galilei, and Galileo Galilei is an Italian person and a physicist. Galileo Galilei is a physicist and the first person who invented telescope, right? Who invented telescope, right? Answer A. Galileo is the first person who defined speed. He defined the speed considering distance covered per unit time. Newton propounded the law of motion to describe the motion of the bodies and object. Kepler gives the law of planetary motion. What are the 3 planetary motion of Kepler's? Number 1, law of the planetary motion is also known as the laws of elliptical. Number 1, the laws of elliptical. The laws of elliptical. That means the journey of the planets around the sun is elliptical, right? Here is the elliptical, right? And here is sun, like this. So all the planets revolve around the sun in the elliptical motion, like this, all right? Like this. When we are talking about the planets, they are around the sun, revolving around the sun in the planetary motion, in the elliptical motion, and the sun, with the sun's center placed at one focus, it is known as the elliptical or the laws of elliptical. Second law of the Kepler planetary motion is an imaginary line formed from the sun's center to the planet center will sweep. Here is, imagine here is a earth, right? The center, a imaginary line from the other planet sweeps out equal portion at equal time intervals, the laws of equal areas known as the laws of equal areas, right? And what is the third law of motion? The ratio of the squares of any two planets period equals the ratio of their average distance from the sun, the harmony's law, known as the harmony's law. All these are the three Kepler's planetary motion law, right? Now, comes to the next question, question number 5. What is the correct equation for finding the acceleration? For finding the acceleration. Now, tell me, what is the acceleration? What is force? Now, when we are talking about force is equal to ma. Momentum, when we are talking about momentum, m into velocity, right? And when we are talking about acceleration, what is acceleration? What is the formula of acceleration and what is acceleration? You must know, you must understand the thing that acceleration is defined as the rate change of velocity, the rate change of velocity with respect to time. That is, acceleration is equal to v minus u upon t is known as acceleration. Also, the unit of acceleration is meter per second square. Meter per second square, it's the unit of acceleration. Clear? When we are talking about force, we can put this equation here like F is equal to mass into acceleration. So you can put here also v minus u upon t, right? This is called as acceleration. Now what is here is v. V stand for, like, it is final velocity, u is initial velocity, and t is time taken, right? So when we find out average acceleration, when we are talking about acceleration find out final velocity minus initial velocity upon given time. Clear? Now comes to the explanation. The correct equation of acceleration is here. I think I forgot to mark the correct answer. Is option number A is the right answer. The correct equation of acceleration is A is equal to v minus u upon t. Acceleration is defined as the rate of change of velocity with respect to time. Acceleration denoted as A and change in velocity upon change in time. If in a given time interval t, the velocity of body changes from u to v, then acceleration A is expressed as A is equal to v minus u upon t, where u is defined as final velocity of object, v is defined as initial velocity of the object, A is defined as acceleration, and t is defined as time. Clear? Question number 6. Two balls A and B are of 10 kg and 1 kg. Now, here's ball 1 A, 10 kg, its mass, right? Second ball is B, its mass is given 1 kg. Respectively, they are dropped simultaneously from a height of 20 meter. From a height of 20 meter. Which one of the following is correct? A will reach the ground first, B will reach the ground first, both A and B will reach the ground at the same time, or none of the above. What will be your correct answer? Now, when we are talking about drop down from particular height, which of the following is correct? All right. This question, they given the 10 kg and 1 kg for given balls. Mass is the 10 kg and 1 kg. All right. You can also imagine here one ball mass is 100 kg A and another ball is B. Its mass is 98 kg. Now tell me which one on the ground first. So in this question or in this type of question, we need to understand when we are talking about which ball falls on the ground first, there is nothing related to the mass. All right. Whether it is a 10 kg, 1 kg, 100 kg and 98 kg. We have no need in this question of mass. We do not have any need of mass, right? Why? Because when we are talking about that something is falling from such height to the ground, which one touches the ground first? So when something is falling from the particular height to the ground, there's only one thing matter, which is gravity, right? So whether it is a 10 kg or 1 kg, but the gravity is same for both. It's same for both, right? So option number C will be the right answer. Both A and B will reach the ground at the same time. Also, there's one concept in this question. When we are doing this type of question, we must understand when something is at a particular height, like here, this is any object at particular height, right? Height is 100 meter. All right. So when the object is here, is it in static energy? Static energy. And when it starts falls toward the ground, and it will start falls toward the ground, it converted into kinetic energy. It converted into kinetic energy. And what the conservation of energy, law of conservation of energy says that static energy converts it into the kinetic energy. Why? Because this particle is in the moving motion. It is in the moving motion. So both are in the energy, moving energy, and when they are comes to the ground, falls onto the ground, they follow the law of conservation of energy, and both static energy and kinetic energy gets constant, right? Next, answer C. When two balls A of mass 10 kg and B mass 1 kg are dropped simultaneously from a height of 20 meter, then both balls will reach the ground at the same time. Given height 20 meter, initial velocity is 0. Here the initial velocity is 0, right? Final velocity of the ball is given as v square is equal to u square plus 2gh is equal to 0 plus 2gh, right? That means final velocity, that this is the velocity of ball A, this is the velocity of ball V, plus 2gh is equal to initial velocity gets 0 plus 2gh. What we get? V square is equal to 2gh, and we solve the V square, we get under root 2gh, right? So here the final velocity of ball does not depend on its mass. Hence, both the balls will reach the ground at the same time. Right? Now comes to the next question. Which of the following distance time xt graph represents one-dimensional uniform motion? One-dimensional uniform motion. Clear? If an object goes in a straight line, right? If an object goes in a straight line, that object covers the distance which can be represent that can be represented by the distance time graph, right? Uniform motion represent a constant change in displacement. Constant change in displacement per second with respect to time, so per second. All right, second is the unit of time. Where velocity is constant, so here velocity is constant, and where velocity is constant and it performs uniform motion. So which one is the correct representation of xt graph or time distance graph? Option number A will not the right answer. Option number B will not the right answer. Because why? Because option number B shows time is not constant. And option number C also not the correct answer. Why? Because change in velocity is not constant. So the right answer will be option number D, uniform motion. Correct representation of the distance and time where constant change in displacement per second and velocity is constant. Right? Now comes to the explanation. Graph is in option D, represent one-dimensional uniform motion. Uniform motion is a type of motion in which the object covers equal distances in equal interval of time. If the graph of distance time for a uniform motion is plotted, then it would be a straight line as shown below. Here, this is the distance and this is the time, and objects moving uniformly in a uniform motion in a straight line, right? Where constantly displacement change and velocity is constant, right? Comes to the next question. The variation of displacement d with time t in the case of a particle falling freely under gravity from rest is correctly shown in the graph. Option number A, this is the first graph, this is the second graph, distance and time. We are sorry, displacement and time, right? So here you need to understand, the equation of motion, t is equal to ut plus half gt square, right? Where t is equal to ut plus half gt square, where when we are talking about initial velocity, u is the initial velocity and it is 0. So 0, if initial velocity is 0, you multiply it by time, it also becomes 0, right? So both the values are 0 plus half gt square. What we get? Displacement is equal to half gt square, where t is directly proportional to t square, that means time, right? Why? Because we are talking about here displacement and time graph where particle falling freely under gravity from rest is. So the right answer is option number A is the right answer. This is the correct representation, or this is the correct graph for the displacement and time relation. Clear? Correct graph is shown in option number A. Equation of variation of the displacement d with the time t in the case of a particle falling freely under gravity from rest is given as t is equal to ut plus half gt square, where initial velocity is 0 and d is the displacement. Also we denoted as s, right? 0. So when the initial velocity is 0, time also get 0. Why? Because 0 multiplied by any value, it becomes 0. Half gt square, right? D is equal to half gt square. So t directly proportional to gravity or the time square. So here d, displacement, is directly proportional to time square, where if displacement get increases, time also get increases, or the time square. Hence, displacement time graph will be the curve shown in the option A. Right? Next question, a very interesting question. A smooth plane inclined at an angle theta with the horizontal as shown in the given figure. A body starts from rest and slides down on the inclined surface. The time taken by the body to reach the bottom is. Alright, I hope you. Now the question visible. The whole question visible now, I guess. Alright. So, very interesting. This is the very interesting question. And also, I need to tell you one thing. If you are preparing for the UPSC prelims, state PCS exam, you must purchase this book, Prelims Possible by Arihant, because this book have amazing content and various types of questions given in this book, which is coming, which is a previous year question also given in this book, topic wise, chapter wise, summarized theory, and also the questions who are expected to come in your upcoming exam. Now, a smooth inclined plane, right, with at an angle theta with the horizontal, a body start from rest. Now, here is the body mass m, right? So, this is the body at rest, mass m. Here is the net force, we denoted as N. This is the net force. This is the net force. Apply here and also apply here mg sine theta. Also apply here mg. Here also apply here mg, right? And here, which thing is apply here? mg cos theta. mg cos theta. Now, understand this whole question by the equation. When body reaches at the bottom, its displacement along the inclined surface to it. Also, acceleration of the body along the inclined surface is acceleration of the body along the inclined surface A is equal to F upon M is equal to mg sine theta upon m. This is our acceleration. Acceleration equal to F upon m is equal to mg sine theta upon m, right? So, here we get our first equation, that is A is equal to g sine theta, right? A is equal to g sine theta. This is our first equation. Now, when body reaches the bottom, its displacement along the inclined surface is it displacement when the body reaches at the bottom, and displacement also denoted as S, right? So our second equation is sine theta upon this is the displacement. Okay, so our next equation is equal to L is equal to ut plus half at plus half t square, and we got here S is equal to L. This is length is equal to U. Initial velocity is equal to v. Initial velocity is 0, then the time is also become 0, and what we get here, we get A is equal to, and also we know here A. What we get A from here? G sine. Alright, so we are going to put all these values. This n equal to 0 plus half sine theta t square. This is our second equation, right? So here t is square minus 2l upon g sine theta g sine, right? Where L is equal to h upon sine. What is L here? L is h upon g sine theta. H upon sine theta. Right? Now, sine theta is equal to h upon L. Sine theta is equal to h upon L. Here, t is square is equal to 2h upon g sine squared theta, g sine squared theta, and t is equal to 1 upon sine theta. This is the t square. Now open this t square. We get is 1 upon t or 1 upon sine theta, 1 upon under root 2g upon under root 2h upon. This is our final equation. This is our final, right? So which one is the correct answer? I think this is the option number C will be the right. Option number C will be the right. Right? The next question. The given situation is shown in the figure. Here they take mass. Right? The constant of the body at rest, they started from here as m. The given force is here g sine theta. Towards to the ground is g, and towards to the hair g cos. Right? This is the h height. This is angle theta in triangle AB. In triangle ABCD, sine theta is equal to h upon L. L is equal to h sine. Right? From the second equation of motion, h is equal to ut plus half ac square. This is the second equation of motion. We apply here, and what we get? L is equal to 0. Initial velocity is 0, and time also gets 0 after plus 1 by 2 g sine theta square. A is equal to g sine theta. Right? From the first equation, how we calculate A is equal to g sine theta, we almost discussed here. Right? So h is equal to sine theta. Why we write it down here? Because L is equal to h plus sine theta we get from here. Right? So 1/2 g sine theta t square. T square comes out here, and 2h upon g sine square theta. This is the t square. When we open it, t square, what we get? T is equal to 1 upon sine theta under root 2h upon g. This is the correct explanation of this question. Moving on to the next question. 10. If a feather, a rubber ball, and a wooden ball are falling freely simultaneously from the same height in vacuum. Now the question is talking about the vacuum, not in the Earth's surface, not the Earth's atmosphere, not it is talking about the gravity. Now the questions about the vacuum. Right? The feather will reach at the ground first. The rubber ball will reach at the ground first. The wooden ball will reach at the ground first. All the three will reach at the ground together. Option number E. None of the above, more than one of the above. Which one is the right answer? Tell me. Which option is the correct explanation of this question? So, if a feather, a rubber ball, and a wooden ball are falling freely simultaneously from the same height in the vacuum, all the three, a feather, a rubber ball, and a wooden ball, all the three will reach at the ground together? No. This is option number D is the wrong answer. Option number E, none of the above. Oh, sorry. Option number D is the correct answer. All the three will reach at the ground together. Why is it so? Because the time required to hit the ground depends on the acceleration of the object, which is in the case vacuum. This is only in the vacuum. Right? Option number D will be the right answer. Why? Because G is same here for all. When we are talking about feather, when we are talking about rubber, whether it is a wooden, G is same for all the three particles, all the three bodies are given in the question. Right? If a feather, a rubber ball and a wooden ball are falling freely simultaneously from the same height in vacuum, then all the three will reach at the ground together. The time required to hit the ground depends on the acceleration of the object, which in this case, that means vacuum, is v. And v is the same for all the three objects. Hence, feather, rubber, ball and wooden ball will hit the ground at the same time. Alright. Now, how many of you understand the difference between capital G and a smaller g? And a small g. Capital G shows gravitational constant. It is gravitational constant. That means it never change. It never change. And when we are talking about small g, it is a gravitational acceleration. Gravitational acceleration. That means small g's always get change. Why? Because it has gravitational acceleration. It always gets changed, but the capital G never changes gravitational constant with respect to Earth when we are talking about the Earth surface. But in the question they asked about the vacuum, that means here G is the same for all the three objects, right? Now comes to the next question. Question number 11. A bomb is dropped at a point. This pilot observed that the bomb traverses a curved path and falls some distance behind that point. The bomb traverses a curved path and falls some distance ahead. The bomb drops vertically downward, or the bomb remains stationary in the air for some time. What do you understand by this question? Tell me. So, the right answer will be of this question, option number B. The bomb traverses a curved path and falls some distance ahead. Why is it so? Because when a bomb dropped at a point from a moving aeroplane, then pilot observed that the bomb traverses a curved path and falls some distance ahead. That means this is because dropping of bomb from a moving aeroplane is similar to horizontal projectile motion. You remember horizontal projectile motion, that means they are talking about this type of motion. This is the horizontal projectile motion, and in this projectile motion the path is covered by, called as parabolic path. Parabolic path, right? When a bomb is dropped at a point from a moving aeroplane, then pilot observes that the bomb traverses a curved path and falls from some distance ahead. This is because dropping of the bomb from a moving aeroplane is similar to the horizontal projectile motion. Horizontal projectile motion, where the peak point is called as range. This is the angle of, this is the point of projectile, and when we are talking about theta is the angle of projectile, right? So motion from a given height due to horizontal velocity of the bomb at the time of the dropping, bomb cover some horizontal distance from the point of dropping, hence it will fall some distance ahead from the point of dropping, right? Further questions we discuss in another class for tomorrow class. So this is the IS with Arihant, and this is the book of Arihant, Prelims Possible. And पहली बार में prelims par, that means if we are talking about Indian history, also Indian history available in the prelim possible, geography, Indian geography and world geography book available with the prelim possible, Indian polity, Indian economy and general science. All the subjects are really very important for your UPSC and PCS state PCS exam. So you must have purchased this book. If you do not buy yet, so go and purchase the book, because this all these books really having a good and amazing content in that. And from the book we are talking about such in a very good manner, they are providing you a content step by step. Also they put here very important questions in the book. And if you do not subscribe the channel yet, subscribe the channel, hit the bell icon to get the all notification on time, and share this class with your friends, with your relatives, with the aspirants who are really very serious about upcoming prelims exam. Thank you so much. We are going to discuss this chapter, continue this chapter further classes. Thank you so much.